So as a continuation of our work on sets, one of the things that I want to kind of look at is these intervals of numbers, which are sets of numbers, but they're what we call continuous sets. So rather than discrete sets, like where we have individual values, 1, 2, 3, 4, 5, whatever, what these are intervals of numbers. So for example, what we want to imagine is that we have a number line, okay? And let's say, for example, 0 is at the middle. And what I have is I'm going to go from 1, and I'll have 1, 2, 3, 4, 5, etc. And then less than 0 is -1, -2, -3, -4, and so on and so forth. Now, one of the things that we get here is that if I'm to do this, let's say, for example, I want to look at a set of numbers. I want to know something about all the numbers that are between 1 and 5. So I'm going to write that down. It's going to go from between 1 and 5. Okay, so I've got 1 to 5. All right. And so some of the numbers that we might see in there, we've got, say, for example, 2.5 is in there. I've got 4.7. 5 is actually going to be in the set. 1 is in the set. 2 is in the set. Another one that you may not know, but it's the square root of 2 is also going to be inside of that set. And so how we're going to write this set is we're going to write it from 1 to 5. And that's because we're going to include 1 and 5. And so that's what brackets mean. So we've got brackets. And the brackets mean to include everything between 1 and 5, including 1 and 5. And so those are the brackets. Now, I could also, say, for example, write, and what I'll do is I'll go from -1 to -3, okay? But I don't want to include -3 or -1. They don't want to be included, so -3 and -1 are not included. But everything else actually is. So -1 and -3 are not included, but everything else in between is going to. We could also do something like, how we represent that is utilizing parentheses. So we'll use parentheses to represent that. Now, one of the other things that I could do if I wanted to was I could actually represent this utilizing half and half. So say, for example, I have 3.5 here, okay, and I've got 7. And let's say I want to include 7, but I don't want to include 3.5. So I want everything in between those two. So what I'll do is I'll actually say, okay, well, on the bottom end, I'm going to have the parentheses to not include 3.5. And then on the top end, I'm going to include 7. So that's going to give me a bracket to include the 7. And so that's how we represent these sets, right? Whenever I write this kind of notation, it's representing an interval. So it's everything in between 3.5 and 7, including 7. Including the 7. So now what I want to do is I now want to take some consideration as to what happens when we start using set notation here with these. Okay, so let's say, for example, I want to go from -3, -2. All right, and I'll include -2. And what I want to do is I want to union that with 4 to 6. Or excuse me, -4 to 6. And we'll include the 6. So we'll go -3 to -2, union -4 to 6. So I'm going to envision this using my number line. And so I've got -3, -2, -1, 0, 1, 2, 3, 4, 5, all the way up to 6. The first set is going to be -3 to -2. We're not going to include -3. We're going to go to -2, but we are going to include -2. And then we'll have -4. Well, that's -4 is over here. We're going to include -4. And this next set is going to go to 6. Now, if you remember, the union means everything that is in one or the other set or both. And it still means the same thing. And so if we look here, right, going from 4 to 6, we've got everything including -3 to -2. So basically -3 to -2 is like a repetition. It's like the redundant part. So consequently, this union is simply -4 to 6. It's just that piece, right? Because -3 to -2 is included. Let's take a look at another one. Let's say, for example, I now do something like I've got 1 to 4, and I want to union that now with 3 to 6. And we'll have those be inclusive. So if we think about it, right, okay, I'm going to draw my picture now. And I'll start, I've got 1, 2, 3, 4, 5, 6, 7, right, so on and so forth. I'm going to start at 1. I'm going to 4, right? I'm going to include both 1 and 4 inside of my set. And then I'm going to go from 3 to 6. So here's 3, and that's going to go to 6. Now we're a union, so we want all or part or both. So notice that 1 to 3 is included in the first set, and then 3 to 6 is included in the second set, and 3 to 4 is included in both sets. So we're going to have all of that. All right, so it's going to go from, this set's going to go from 1 to 6. That tells us everything that we need to know. All right, let's see what happens, say, for example, if what we do is we combine our sets. So let's say, for example, now I want 2, or -2, 3, and I want to union that with 0, -5. So now I've got -2, -1, 0, 1, 2, 3, 4, 5, and 0 to 5, not -5, excuse me, 0 to 5, 5. And so I'm going to go, okay, I got -2 goes up to now 3, but we're not going to include -2 or 3 because we've got the parentheses. And then we'll have 0 to 5. We go 0 to 5. And now what we want to notice is what are all the values that are in one or the other or both? Well, we start at -2. We keep going until we hit 3. But then 3, 4, and 5 are included in our second set. So it's going to go -2 to 5. So we got -2 to 5. And that is the set that is our union. So that's a union. Now an intersection, if you remember, an intersection is what's going to be included inside of both sets. From the standpoint of intervals, it's going to be the overlap of both sets, or all of the sets. It'll be the overlap of both sets. So let's say, for example, I go 3, -2, and I want to intersect that now, and that's the -2 is in parentheses, open bracket, and I want to intersect that now with, excuse me, if I want to go from -2, 3, and I want to intersect that now with 0 to 2. And we'll make those brackets. Now if I draw my picture, I'm going to use some different colors here to kind of help me out with this. I've got -2, -1, 0, 1, 2, 3, and we'll go up to 4. So we're going to start with -2, that's closed brackets, and that's going to go up to 3. And that'll be an open bracket because it's open. Then we're going to go from 0 to 2. What you want to notice is that the intersection is going to be the overlap of both sets. So it's going to be what's included in both sets, and the thing that's included in both sets, both the -2 to 3 and the 0 to 2, is this set 0 to 2. So that's the thing that's included. It's going to be 0 to 2. It's actually included in both. That's your overlap. Let's take a look at another one. Let's say, for example, I go from -1, 0.5, and I want to intersect that now with 0 to 2. So now I'm going to draw my number line again, and I'm going to get, I've got -1, 0, 1, and 2. We'll go -1 to 0.5. So here's 0.5, and that's open. Both are open. And then 0 to 2. We'll notice that the overlap here is going to be there between 0 and 0.5. That's the overlap of the two sets from -1 to 0 and 0 to 2. So consequently, what I'm going to get is I'm going to get that my interval is going to go from 0 to 0.5. That's the interval. Now what we want to notice is that 0 is not included in this set, so we're not going to include it in our intersection. And notice that 0.5 is not included in this set, so we're not also going to not include it in the intersection. And there it is. So it'll go from 0 to 0.5. Not including 0 and 0.5, and that's because 0 is not in the second set because it's a parentheses in the second set, and the 0.5 is not in the first set, it's a parentheses in the first set. Let's take a look at one more example. Let's go from 0 to 3 inclusive, and we'll intersect that now with 1 to 2 not inclusive. So now when I look at this, I'm going to go, here's 0, 1, 2, 3. Okay, 0 is not included. We take it all the way to 3, but 3 will be included. And then in our second set, 1 will be included, but 2 will not. So we have an overlap. The overlap right here, right, takes us from 1 to 2. But notice that we're not going to include 2, right, because 2 is not in this second set. But we will include 1 because 1 is actually included in both the sets. 1 is in this overlap from 0 to 3. Right, this whole overlap has 1 in it, and 1 is also included inside of your second set. So that's basically what we're going to be, how you want to think about the intersection and the unions of sets. Okay, what you want to think about is with unions, it's everything that's in both. Okay, everything that's in both, and so it's going to be inclusive. We add stuff to it. On the other hand, when we look at an intersection, it's going to be the overlap of the two sets. And you want to make sure that whatever number you're putting in, you put in both numbers. Or, excuse me, whatever numbers you're putting in are in both sets. Okay? And that concludes this lesson.